Okay, so in this video, what I'm going to do is I'm going to look at, I don't know how many things I'll get to. Hopefully I'll be able to get to both of them. Doing the difficult part of the homework assignment, this thing with these running averages, I'm going to do that, but I also want to do some plotting as well. Actually, I think I might save the running averages for the next one. So this one, for this video, what I'm going to do is I'm going to compute the number of terms in the Collatz sequences from numbers going from 1 to m. In this case, m is equal to 10. We'll be able to change m later. Of course, that's the whole point of having this as a variable instead of as a fixed number. And then we're going to plot the number of terms in the Collatz sequence. So we're going to use matplotlib. So before I even get to matplotlib, let's just try to get an array with the number of terms in the Collatz sequence. Okay, sorry, I forgot where I was. If you hear noises, that is my 1-year-old son who is with me right now while I make this video. Okay, so at any rate, we have this array. If I print this array, I'm going to get this. Okay, so if I'm going to get this. That's the array, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to compute the number of terms in the Collatz sequence for 1 and put that in an array, the number of terms in the Collatz sequence for 2 and put that in an array, and so on and so forth. Okay, so you might think, so I'm going to create a new array called CAR for Collatz array. Given everything that I said in the previous video on NumPy, you would want to try something like this. So I've got my array and I just want to apply the Collatz function to this array. I'm going to run this, and I get an error here. So the error, the truth value of an array with more than one element is ambiguous. Okay, so maybe there's a couple of ways that we can fix this. If I look down here, it says use a.any, that is the array, or a.all. So if I try this and do any, so let me actually print out. Well, 1, that doesn't give me what I really want. If I try all and run it, that doesn't really give me what I want. So here is a way that we can fix this problem. So the issue is that the way we've written this is it's expecting a number, it's not expecting an array, and so the logic, like if we pass in an array and it says while n is greater than 1, it doesn't make sense. Like if we want to know whether or not an array is greater than 1, like what exactly does that mean? So it doesn't exactly know, Python doesn't exactly know how to interpret it. Luckily, NumPy has a great function called vectorize. So I'm going to say vcol, which means the vectorized version of the Collatz function, is equal to numpy.vectorize of my function Collatz. And now what it's going to do, however it works, let's just think about it as being by magic now. It's going to take this function and make a vectorized version of it. In other words, a function where we can pass in a NumPy array. So I'm going to run this, and then CAR is equal to the vectorized Collatz, vcol of AR. And now when I print it, let me get rid of this. And now when I print it, I should get the thing that I want to have. So if I run this code, I'm going to do exactly what I think I should get. This is the number of terms in the Collatz sequence for 1, the number of terms in the Collatz sequence for 2, the number of terms in the Collatz sequence for 3, and so on and so forth. Okay, now definitely a difference that I need to make. So a definite change I need to make here, instead of a 1, I'm going to put an m. That was the whole point, so I can run this. Now notice I don't have any for loops here, right? I've done everything, but I don't have any for loops. And this is one of the things we like with NumPy. We want to have as few for loops as possible. There is implicitly a for loop here, but what's happening is Python, and NumPy specifically, is doing the explicit for loops. And the reason that we like this is because if we let NumPy handle the for loops, it's typically going to do things faster than we can, just using better programming techniques, but also things like parallelism that we wouldn't have if we just did an explicit for loop. So now if I say m is equal to 100 and I run this, okay, much easier to deal with than maybe what we were dealing with before. Okay, so this is good. But now what we want to do is for every n, or I can't remember, I think I said for this video I want to introduce matplotlib before I do the homework problem. So I'm going to come up here, import matplotlib as PLT. So I'm going to run this. It's going to import the library. And of course, I get this error message because I have not installed matplotlib. So I'm going to do that now. I'm going to save this, close it. I'm going to close out Anaconda. I don't really know why, but I like to, whenever I install a new thing, I like to completely close out Anaconda. So Anaconda, activate math 696 S24, and then do conda install matplotlib. Okay, and I will probably pause the recording here in just a minute. Yep, okay, while it installs.
I also have a class.
Okay, so now what I want to do is I've got the numbers 1 to 10, or 1 to m, and I've got the corresponding Collatz array. What I want to do is I just want to, on the horizontal axis, like plot the numbers, you know, have the horizontal axis be 1 to 10, the vertical axis is going to be the number of terms in the Collatz sequence, and I just want to plot those. So it'll be like a scatter plot. Okay, so up here I have, I added matplotlib. You saw the beginning of that. And I needed to add pyplot right there because that is the sub package in which everything is. Really everything that we're going to be using. Okay, so this is very, very good, very intuitive to use. So I'm going to do PLT, and I would ordinarily have to write that whole thing out, but since I did as PLT, I just need to write plot or PLT. There's a function in pyplot called plot, and I'm just going to do AR. So that's going to be the horizontal axis, and CAR, that's going to be the vertical axis. And when I run this, I'm going to get something pretty close to what I want. Okay, so maybe I don't want the lines because having the Collatz sequence in between doesn't really make a whole lot of sense. But this is a basic plot. If you have two arrays, it's going to make a line graph plot like this. But let's just say instead of having a line, we want to have blue asterisks. Well, the way we do that is the third argument is going to be blue asterisk like this. Here's the things for pyplot. Here's everything for pyplot. You can look at pyplot and do all of the different, look at all of the different things. Here's all of the different kind of things it knows how to do, shapes it knows how to draw. But if I come back here and run it, I should get blue asterisks, and this is exactly what I get. And so this is a plot, and it just indicates, almost it looks kind of almost random in a sense, how the terms, how many terms there are in Collatz sequences. If I make this go up to, let's say, 20 and run this again, okay, it starts to look a little interesting. We kind of get, some interesting patterns. These look like pairs going on and so on and so forth. I will let you look at the pyplot documentation to see how instead of having 2.55, we could just increment by integers, since that's what really makes sense for what we're dealing with in this problem. Okay, so I think that is what I want to talk about now for pyplot. Again, very basic introduction to pyplot. So that's what I want to talk about for now. And this week and next week, we'll look at maybe more advanced uses of pyplot. But again, look at how intuitive it is to use. This can kind of be your entry point and how you use pyplot to do other things as well.